All right, guys. So just like I promised, I'm going to show you guys how to do some of these redox reactions. And first, we're going to start off with how we assign oxidation numbers. So we start off kind of slow because, trust me, this progressively gets harder and harder as we continue on, especially when it comes to balancing them. But it all starts with the first assigning oxidation numbers to compounds, because in order to figure out what's being reduced and what's being oxidized, you got to be able to figure out where the electrons are going. Okay. So it's actually not too hard. It's not too difficult, but we first want to start off with understanding like what are some of the rules. Like, so for example, if you got like a compound that is a pure compound, let's say like oxygen gas, right? Now, this is real simple because it's bonded to itself. So therefore the oxidation number here is going to be zero. So anytime you see a diatomic, oxidation number is always going to be zero no matter what. Now, if you see an oxygen bonded to anything else, let's say, for example, something like sodium dioxide, so Na2, right? And then oxygen like that. Well, oxygen typically will always be -2 as an oxidation number. Other things that we should probably know as well, if you have like any kind of metal, let's say like argon, not sorry, not argon, but like, I don't know, gold, right? It's gonna have an oxidation number of 0 because it's not bonded to anything. So it's those kinds of things. All right. Real simple things just kind of to remember. But ultimately, what it comes down to is when we add up all of our charges, it should equal what the charge of the molecule is. So, for example, if it's a neutral thing, let's say like this one right here, when I add these all up, it should equal 0. So we see that we have -2 for oxygen, and I have 2 sodium. So whatever I add to -2 has to be equal to 0. So what I'm going to do, I'm going to add 2 of them, right? Or sorry, not 2, but 1, right? Because 2 times +1 is, 2. So when we have these two, it's going to be +2 plus -2, which is going to give us 0. So the oxidation number for sodium here is going to be +1, and the oxidation number for oxygen is going to be -2. Real simple things like that. All right. Other things you probably know, fluorine, for the most part, typically will be -1. Alkali metals will always be like, for example, sodium, potassium, lithium, those guys right there. For the most part, always +1. And everything else we kind of just figure out as we go along. Not super difficult, but it's better if we just kind of practice some of these things and kind of go there. All right, so I'm going to use the ones from the notes. Start off with an easy one. So let's figure out the oxidation number for iodide. So that's I2. Now, if you remember our rules for this one, it's real simple because this is the diatomic, right? So it should have an oxidation number of 0. Nice and easy. Okay, let's go to a more difficult one now. So as our next example, let's do sulfuric acid, H2SO4. Okay, and this is a neutral atom. So there is neutral molecule, so there is no charge at all. Okay. So first thing we're going to do is we're going to figure out our oxidation number for each of them. We always start with the easiest one, which in this case is going to be oxygen. Since oxygen here is always going to be -2, but there's 4 of them, so we're going to put a 4 multiplied by -2. When we do that, that gives us -8. Now we're going to jump over here to hydrogen. If you ever have 3 elements in a compound, right, and one of those happens to be hydrogen, hydrogen typically is always going to be +1, right? So since we have 2 of them, that's going to be 2 times +1, okay? And that's going to give us a grand total of 2 positive. All right. Now remember, because this is a neutral atom, when I add all of these guys up, it should equal to 0. So I guess you could do a little bit of algebra here to figure out what the oxidation number is going to be for sulfur. Or you can just kind of look at it and say to yourself, well, if I have 2 and I have -8, and, I don't want to insult your guys' intelligence, you can kind of figure it out from there, right? So whatever it is, because I have a negative number over here, a big negative number, -8, right? I only have a +2. When I add those two together, that's going to give me -6. Well, I have to get it to 0. So in order for me to do that, what I'm going to say to myself is, and I'm doing all the algebra in my head, but basically I'm saying that the oxidation number for this sulfur, since there's only one of them, has to be +6. So it's going to be just like that. Okay. Because when you add 2 plus 6, that gives you 8, minus 8, that gives you 0. So the oxidation number for the sulfur is going to be 6. So if I were to assign oxidation numbers to this compound, it would be Here's my sulfuric acid. Hydrogen all by its lonesome would be +1. Oxygen by its lonesome would be not -2. And as we just discovered right now, sulfur's oxidation number is going to be positive, what we say, 6, and just like that. All right. So that's one of them. Let's try another one now. Let's try a polyatomic. So let's say, for example, that we have this compound right here. Let's say we have carbon dioxide, CO3, 2 negative. No, did I say carbon dioxide? Sorry, carbonate. My fault. See, I'm on brain mode right now. I can't think. CO3, 2 negative. Same rules apply, just like we did before. All right. So don't forget that the oxidation number for oxygen is always going to be -2. Not always. Like, for example, if it's peroxide, it won't be because hydrogen is +1. But for the most part, for the ones that we're working on, it's always going to be this one right here. So we're going to give this one a -2. And there's 3 of them. So we're going to multiply it by 3. A little arrow up like this is going to give us a grand total of -6. Right? And now we got to figure out what carbon is. Now remember, because the charge of this thing is -2, so whatever carbon is, when I add it to -6, it has to be equal to -2. All right. Like I said, there's a little bit of algebra here, or if you don't want to waste the time, you don't have to do the algebra. But just for the purposes of teaching you guys this, let me do a little bit of algebra here. So we're going to call carbon just C, and we're going to say -6, all right, is equal to -2. Right? If I do the algebra for this, I'm going to add 6 to this side, add 6, I can't talk, add 6 to this side. That gives me a sum of carbon equals +4. So I just did it right there, which most of us will probably just do it in our heads, but it's good to kind of see it first so you can see where I'm actually getting this from. So carbon's oxidation number, since there's only one of them, is going to be +4. And when I do that, right, it gives me that -2. So if I go to rewrite these again, right, so I can write the actual oxidation numbers for each of these. Carbon dioxide, CO2. We still know that oxygen is going to be -2. And we still know that carbon here is going to be +4. All right. So we assigned oxidation numbers for all of those. Pretty simple. Not too hard. So not too bad so far. Let's try one more just to kind of get the sum of this one. Let's do the more difficult one on the notes, if you want to call it that. So we got, it looks like sodium chromate. Yeah, I think that's what it's called. Sodium chromate. So you have 2 of those. You have chromate, which is Cr2. This is the polyatomic, by the way, guys. It's a big one. Oh my goodness. Right? Sodium chromate. Well, I didn't even do potassium permanganate. I should have done that one. You guys would have loved that one. Now, first and foremost, since it is a neutral atom, it means it's gonna equal 0. All right. So we're gonna do the same thing just like we did before. Okay. Now we know that oxygen here is going to be -2. So we're going to say -2. And there's 7 of them. So we're going to multiply it by 7. Put that up here because I like the space. You don't have to do it this way, but this is the way I do it just to make it a little bit easier for myself. So I got -14 for that one. And don't forget, because it is neutral, it's going to be equal to 0. All right. Now, sodium, because it's an alkali metal, we know for the most part, oxidation number for these guys are always going to be +1. Right. But since there's 2 of them, we're going to multiply that by 2. Put that up here. And we're going to say 2 positive. Cool. So the only thing we have to do now is we have to figure out what the chromate is. And since we have 2 of them, we're going to do it as such, like we normally would, right? So for chromate, here's how we're going to do this. We're going to say that our equation is going to be equal to this. Now I can do it in my head, right? Or I can do it the algebra way, because this is the bigger one. I'm going to do it the algebra way. Just I want to figure it out that way. So before I even continue with this, I'm going to simplify my equation just because I don't want to have too much of this going on. So 2 minus yeah, 2 minus 14 is going to be -12. So I'm going to say, in this case, I'm going to call chromate Cr minus 12 equal to 0. Now, there's one thing I need you to remember. There's 2 chromates. Now, remember, we're trying to figure out the oxidation specifically of one of the chromates, not all of it all together. I mean, you can do this math beforehand or you can do it afterwards. I just like doing it like this. That way I know what it is because I know how to multiply. So I'm going to say 2 chromates. That's what I get. That's what I get each one of these to be equal to. All right. So let's do the algebra. Let's say plus 12, plus 12. All right. This now becomes 2 chromate. Oh, that's an ugly chromate. Let's try that one more time. Chromate is equal to 0. Oh, not 0. Dominguez, come on. Positive 12 or just 12. We're going to divide by 2 for each of these. Divide by 2. And we get each of these chromates to be equal to 6. All right. Pretty simple. So positive 6. So bring this up here. Now, because there's 2 of them, that's going to be the same thing as saying positive 12. And when I go to add all of this stuff up, it will give me 0. So the oxidation numbers for each of these, just like we said before, for sodium chromate Cr2O7 is going to be -2, +1, and lastly, but not leastly, +6. And just like that, ladies and gentlemen, that's how you figure out oxidation numbers or how to assign oxidation numbers for molecules. If you have any questions, send me a message on Teams. Next video I'm going to show you guys how to balance one of these bad boys and actually how to figure out what's being reduced and what's being oxidized. All right, guys.